Hello friends, today we'll discuss about waveform generators and voltage regulators under linear integrated circuits. In this class, I am going to tell about the oscillators, what are different types of oscillators are available, and in what way it will be used for commercial applications as well as industrial applications, many things. So among these waveform generators, we have sine wave generator, square wave, triangular wave, sawtooth wave. Today we will discuss about one of the sine wave generators that is most familiar. Sine wave generator is called as RC phase shift oscillator using operational amplifier. See here, this is the circuit diagram of RC phase shift oscillator. Why this is called as RC phase shift oscillator? Because the oscillator is performed by the oscillation is performed by the R and C component, the resistor and capacitor components. For any oscillator, it needs two parts of the circuit. The one is amplifier part, the another one is feedback network. The feedback network is used for making oscillations. It is made up of capacitor and as well as resistor. We know already about what is the condition for oscillation, Bar-Gaussian criteria, right? The Bar-Gaussian criteria is nothing but the total phase shift around this circuit is 360 degree or 0 degree, and the gain should be greater than or equal to 1. The gain is nothing but it is including the gain of the amplifier stage as well as the gain of the feedback network. The gain of amplifier is called as A and gain of feedback network is beta. So A beta should be greater than or equal to 1. So that is the minimum criteria we are going to maintain, that is to make a circuit to oscillate. So beta is the gain of the feedback network. So gain of the feedback network, here it is what the feedback network, the output is V0 and input is Vi. So we have to take V0 by Vi, that is equal to beta value. Right. So in RC phase shift oscillator, the amplifier stage is nothing but inverting mode. Since it is an inverting mode, the phase shift of amplifier is 180 degree. So what is the condition for any oscillator? The total phase shift should be 0 degree or 360 degree. And since this inverting mode of amplifier is producing 180 degree, the remaining 180 degree we are going to achieve by the three stages of RC network. So for the first RC network, this is the second RC network, third RC network, and all these component of capacitors are identical. Similarly, all these resistance values are identical values, right? So each stage will produce 60 degree, 60 plus 60, 120 plus 60, 180 degree. So this feedback network alone will produce 180 degree, and another 180 will be produced by this inverting mode of amplifier. So totally we are getting 180 plus 180, 360 degree. So now this condition is satisfied, the feedback condition is satisfied. Okay. So the minimum requirement for making any circuit for frequency, that is for oscillation, we need to get the overall gain should be greater than or equal to 1, as well as the total feedback is equal to 0 degree or 360 degree, coming under Bar-Gaussian criteria, right? So this inverting mode will produce 180 degree and is given to the feedback network, it will give another 180 degree. So because of this, it will the circuit will be oscillating, right? So now here and see here, this is input signal. It will act as the input for the feedback network. This is the output signal. So the phase shift between input to the output will be 180. And this is the complete transfer function of this feedback network. This is we have to calculate by applying the nodal analysis. We are going to calculate what is the beta value, that is the gain of the feedback network, and frequency of oscillation. F is equal to 1 by 2 pi RC root of 2 into N, where N is total number of stages. Here we have 3 stages, so it will be root of 6. So frequency of oscillation for 3 stage RC network is equal to 1 by 2 pi RC root of 6. Right. So what are the advantages of this RC network? It is very simple to design. It can produce output over the audio frequency range and produce a sinusoidal output waveform, and it is a fixed frequency oscillator. But what are the drawbacks? In this case, we have 3 stages of RC network. Each stage will produce 60 degree of phase because of lead lag combination of resistor and capacitor with respect to voltage. Suppose if any of the value is not matched, suppose among these 3 capacitors, the one capacitor value is little changed, what is happening? Then we cannot achieve the Bar-Gaussian criteria. So because of these value changes, it may changes the phase shift. Because of that, the 180 degree achievement will be getting failed. So that is one of the drawback in this case. If you want to change the phase, then all the components value will be simultaneously changing. That is not possible. Okay, this is one of the drawback of this RC phase shift oscillator. And the frequency stability is very poor due to the changes in the values of various components due to the effect of temperature and the aging of the component. And also there are many number of resistors and capacitors are added in the feedback network. That is also that is also drawback for this RC phase shift oscillator, because the voltage drop will be increasing and it will affect the frequency parameters. Right. So with this we will complete the RC phase shift oscillator, and to the next class we will discuss about Wien bridge oscillator. Thank you.